Good day, everyone. Welcome back. I hope that you're doing great. What we're doing in this video is the final lesson in Unit 4 of Math 10C, which is called Exponents and Radicals. This lesson is found on page 24 of your unit handout for the West Country Outreach students. It deals with what are called rational exponents and radicals. There's a pretty serious typing mistake that I've made when I typed this out and prepared it for you. It should say rational exponents and radicals, not, as it is in your handout, integral exponents and radicals. So just take a minute and make that correction to your note package. The reason why that's very important is we have studied different number systems and sets of different numbers in the previous unit, and rational numbers were numbers that could be written as a fraction of integers. And what we're dealing with in this lesson is looking at the meaning of an exponent if it is a fraction. And that's why we have to call those exponents rational exponents, because they're fractional in today's lesson. So to begin with, I want to go through some terminology relating to radicals. When we see something like what you're looking at on the screen, it's important that you understand that that symbol, that what we could typically call a root symbol, is called a radical sign. What is underneath the radical sign is referred to as the radicand, and the little itty-bitty number that's wedged in the V part of the radical sign is called the index. So the radical sign is the root sign, the radicand is what's underneath the root sign, and the index is that little tiny number wedged in there. It's important that you understand the terminology, just like anything else in math or any other subject matter. If you don't understand the terminology, you're not going to be able to communicate effectively your understanding of the math. So the index of a radical, I'll remind you, the index is that little tiny number I've highlighted in green, tells you something about what we're doing. If the index is 2, we're looking at a square root. And I'm going to review with us together as a group here in a little while what a square root means and what a cube root means, etc. If the index is 3, we're dealing with a cube root. If the index is 4, well, that would be what we call the fourth root. And it goes on and on. We can talk about fifth roots and sixth roots, and there's really no end to this. Although typically in this course we will be dealing with roots that go up to maybe the fifth root. When you get into Math 20-1 and 20-2, you will explore radicals that are more complicated and more work is involved in figuring out their values. So just to go through, I think what you should already know from the previous unit and also from grade 9, just to go through some previous skills here, when we look at this root 81 is how we would pronounce it, we don't have to write the index for square roots. We know that this is the square root of 81, and the index, though unwritten, is really a 2. So the index of this thing that we're looking at is 2, the radicand is 81, and it means the square root of 81. The square root of 81 is equal to 9, and there's a reason for this. It's equal to 9 because when you multiply 9 by itself twice, you get 81. And I want to make sure before I go on, you understand the connection between what's on the left-hand side of the screen and what's on the right-hand side of the screen. The reason why we're looking at a number multiplied by itself twice to give the 81 is because the index is 2. And I'm perfectly aware that everybody can grab their calculator, and find the square root function on your calculator and enter 81 and figure out that it's 9. But in this lesson it's important, and in high school math it's important, that you understand the square root of 81 is 9 because 9 multiplied by itself twice will give you 81. Or the square root of 81 is 9 because 9 squared gives you 81. Let's take a look at this one. Well, this is an index of 3. The radicand is 64. And what it means is the cube root of 64. The cube root of 64 happens to be 4. And this is not, it's very similar to other things we've done in this course and in this unit specifically. This is not about just using your calculator. It's about you understanding the process involved. And in this case, there's a connection between the cube root of 64 and the number 4. The number 4 is the cube root of 64 because 4 multiplied by itself 3 times gives you 64. So again, it's the index which tells you how many times you have to multiply the mystery number by. And again, I could show that to you on your calculator. I could say 4 times 4 times 4. That gives me 64. I could say 4 cubed gives me 64. So the cube root of 64 is 4 because 4 times itself 3 times gives you 64. If you wanted to use your calculator and you're using my version of the calculator that I have up here right now to find the cube root of 64, which is a skill you do need to know, you go to the Math menu. That's the Math key, which is right underneath the Alpha key. And you hit Math and you scroll down to option 4, or you choose option 4, and then you can enter 64. I'm not particularly happy with what that looks like on my calculator screen. That 3 is really something that when you write it out, it should be wedged inside there, not hanging outside like it is on my calculator screen. And you get 4. If you have a graphing calculator that is in a different mode, then when you go to your Math option and choose cube root, it looks a little bit better. It's got that 3 up a little bit higher, and then we have 64, which we enter, and you get 4. Moving on, if we take a look at something like the 4th root of 625, the index is 4. The radicand is 625, and it means the 4th root of 625. Now, the 4th root of 625 is a number which, when multiplied by itself 4 times, gives you 625. So, I mean, we could start trying numbers. We could try 3 times 3 times 3 times 3. No, we don't get 625. We get 81. Which, by the way, if you stop and think about it, means the 4th root of 81 is 3. But we're looking for the 4th root of 625. Maybe it's 4. 4 times 4 times 4 times 4. If you are good with your number rules for multiplication, you will see that when you multiply 4 by itself 4 times, you're not going to get a number that ends in 5. You're going to get an even number. So you get 256. So 4 is not the 4th root of 625. 4 is, however, the 4th root of 256. If we try 5, 5 times 5 times 5 times 5, we get 625. Of course, you can abbreviate that by trying 5 to the 4. So it's equal to 5 because 5 multiplied by itself 4 times gives you 625. Now, if you want to know how to use your calculator to calculate the 4th root, on a calculator like mine, I have to enter the number 4, go to the Math option, and choose this option. And I really don't like this because it does not look like it should. What that looks like is 4 times some root. But my calculator uses this set of symbols to mean the 4th root, and I could put 625, and I get 5. If I take a look at my calculator in a different mode, which many of you will have this mode enabled, you go to the Math option and choose the xth root, and that allows you to put the number 4 up here. And again, it looks, I guess, a lot better than the calculator on the left. And then we can enter 625. Now, I don't use this mode very often, so I'm just curious. I think, but we're going to find out, I could just go 4 and then xth root, and it will insert that 4 in there. So you enter it in the same order that you would enter it in the calculator on the right as the left, but it looks a lot better. So now that we have the terminology out of the way and we have a kind of a basic understanding of what roots mean, we're going to learn about the connection between exponents that are fractional and roots or radicals. And we're given permission here to use our calculator to do this warm-up. It says on your calculator, evaluate each of the following. So on my calculator on the left, I'll pull up both my calculators. The calculator on the left is the one I prefer. When I enter this and I say 25 and I hit raise to, which is this little roof-shaped thing above the divided by button, and I enter an exponent now, if the exponent is 1 over 2, I need to put that in brackets. Otherwise, my calculator will take 25 and raise it to the 1 and calculate what that is, and then it will divide that answer by 2. I do not want that to happen. I want 25 to be raised to the 1 over 2. So I have to put it in brackets, and I get 5. Now, if you're using the calculator in the other mode, or a calculator that is always in this mode, when I enter 25 and I hit the raise to key, which is still the button above the divided button, it pops the cursor up into the exponent area, and I do not need to put a set of brackets there. This is one of the advantages of having your calculator in this mode. Bottom line is I still get 5. So 25 raised to the 1 over 2 gives you 5. Let's take a look at the next one, which is 9 raised to the 1 over 2. Again, I'll just pull up both of my calculators. On my calculator, I either have to go 9 raised to the bracket 1 divided by 2, or what I would probably do is just go 9 raised to the 0.5, because 1 over 2 is 0.5. We get 3. 9 raised to the 1 over 2 here gives you 3. So 9 raised to the exponent of 1 over 2 is equal to 3. What does an exponent of 1/2 mean? Well, it looks like it means the square root. Because the square root of 25 is 5 and the square root of 9 is 3. We suspect it means the square root. We can verify that with some other things. For example, I know the square root of 16 is 4. So let's see, 16 raised to the 0.5, yeah, it's 4. What about 100? I know the square root of 100 is 10. What if I raise 100 to the 0.5, which is 1 over 2? I get 10. I could even do this with numbers that are not perfect squares. Like I could take the square root on my calculator of 78 and look at the decimals. We should know that that is an irrational number when that happens. These decimals are going to go on and on forever without any repetition of single decimals or groups of decimals. But let's try now 78 raised to the, in brackets, 1 divided by 2. You get the same set of decimals. So we're convincing ourselves that that's what it means, and it does. We're not going to lie to you here. The fact of the matter is, when you have an exponent of 1 over 2, an exponent of 1 divided by 2, or in decimals 0.5, it means the square root of the radicand. Actually, I shouldn't say that. When we're talking about exponential form, there is no radicand. I should say the square root of the base of the power. I could tell you this, basically. A raised to the 1/2 is the same as the square root of A. There is very little that you learn in Math 10C that you do not need to know to move on to the next level and then the next level. This is a very important idea or fact or rule, if you like. You just need to know this. From now until the end of your math career, whenever that is, whether it's grade 10, 11, 12, university, whatever, you need to know that an exponent of a half means you're going to take the square root of the base. Let's move on and take a look at warm-up 2. Warm-up 2 asks us to figure out what 64 raised to the 1/3 is. I'll use the fancy calculator this time, the one where I don't have to use brackets. So 64 raised to the 1/3 happens to give me the number 4. And if you use a different calculator, you'll still get that. Okay, let's write that down. This is equal to 4. What about 8 raised to the 1/3? 8 raised to the bracket 1 divided by 3, end bracket, gives me 2. So what's the connection here? Well, you can just make a mental note. I'm just hanging out on this side of the smartboard right now, so I'm going to talk about B first, that 2 multiplied by itself 3 times happens to give you the base of 8. Which means that 2 is the cube root of 8. Let's see if that's true over here. If I take 4 and I multiply it by itself 3 times, does it give me 64? Well, 4 times 4 is 16. You can use your calculator, but 4 times 4 is 16. 16 times 4 is in fact equal to 64. So what we're discovering here is that 4 is the cube root of 64. We can try this with all kinds of other numbers, but I'm not going to use time up in this video to do that. An exponent of 1/3 means that it means the cube root of the base. And I could abbreviate that, and this is the nice thing about mathematical language. I can use words, and words require a little more work. You have to think things out very carefully. Or you could just write it as a statement. If I have some base, I'm going to use B this time as the base, raised to the 1/3. That is the exact same thing as the cube root of the base. And I want you to pay careful attention to where I wrote that 3 in the cube root. Even in the line above where I wrote the cube root of 64 and the cube root of 8, that 3 is really wedged in there. What you don't want to do is be, well, sloppy with it and just have that 3 as a big 3 written out in front, because then it can look like a coefficient. So an exponent of 1/2 means take the square root of the base. An exponent of 1/3 means take the cube root of the base. Now, I'm not sure why I have number 5 here. I'm just going to refer to my notes. And it jumps in my note package from 2 to 5. I really don't know why that is. Don't worry about it. It says, evaluate 9 raised to the 5/2 using the exponent laws. We're not using our calculator. We will check it with a calculator in a second. The first thing I want you to notice is that 5/2 is 5 multiplied by 1/2. Because if we write 5 as 5/1, then when we multiply fractions, we have this multiply through on the top and multiply through on the bottom rule. So we can write 5/2 as 5 times 1/2. We could also write it as 1/2 times 5. Now, why am I talking about this? It's because I can write 9 to the half raised to the 5, and that is the same thing. This is the exact same thing as 9 to the 5 halves. I'm going to erase this part in the middle because we don't really need it anymore. Why are these two things the same? They're the same because of the rule that we call a power of a power, where we have, it doesn't matter what letters I use, x raised to the m raised to the n. We have learned, and we've used this a lot over the past probably 5 days of you practicing this stuff, that you multiply the exponents together. So these two exponents multiplied together will give you this exponent. So 9 raised to the half, quantity raised to the 5 is the same as 9 raised to the 5 halves. But that part that's inside of the brackets, 9 raised to the half, we just learned a few minutes ago that that means the square root of 9. So that means we can write 9 to the half, then raised to the 5, as being root 9, then raised to the 5. And hopefully we know that the square root of 9 is 3, so this is 3 to the 5. Now, I'm not expecting everybody to be able to multiply that out without a calculator. So I'm just going to leave it as 3 to the 5 because that is not the important part. If we go to the calculator now, I'll go to my version of the calculator, and we want to figure out what 9 raised to the 5 over 2 is. On this calculator, this version, I have to put the 5 over 2 in brackets. And I get 243. Now I'm going to check what 3 to the 5 is, and it's 243. In calculating 9 to the 5 halves, I could have taken 5 divided by 2 first, which is 2.5, and now go 9 raised to the 2.5, but I get 243. So if we use the exponent laws, to get here, or if we use a calculator, they are the same. It checks out. So number 6, evaluate 8 to the 2/3 using the exponent laws. Well, riding on the heels of what we just did with the previous warm-up, 8 to the 2/3 can be written as 8 to the 1/3, then in turn raised to the exponent of 2. Because a power of a power, which is what we're looking at, involves taking the inner exponent and the outer exponent and multiplying them. So what this is 8 raised to the 1/3 times 2 over 1, which is 8 raised to the 2/3. We learned in a previous warm-up that an exponent of a third means cube root. So what's in the brackets, 8 to the 1/3, could be written as cube root of 8 squared. We know what the cube root of 8 is. The cube root of 8 is 2 because 2 cubed gives you 8. Or, and I really want to highlight this, I don't want it, there's 2's flying all over the place. I don't want you to be confused. This is in fact equal to 2 because 2 is the number that you multiply by itself 3 times to give you 8. We still have to raise it to this 2 over here, and we get an answer of 4. So the question is now in B, what is it that we get when we check this with a calculator? So what do I get when I take 8 raised to the 2 over 3? Well, I get 4. So the exponent laws match with the calculator. Now we're learning something from this, and it's about to be summarized. So this all checks out. What have we learned from all of these warm-ups? It says in the box below, summarize the above by writing rules or a rule for a base raised to a fractional exponent. Well, I'm just going to start off with the basic rule, which says that when you have a base raised to 1 over n, that is going to be the nth root of the base. In other words, we learned in the first set of warm-up questions, if the exponent is 1/2, you take the square root of the base. If the exponent is 1/3, you take the cube root of the base. But what we learned after that is that when you have a base raised to a fractional exponent, what you can do is take the nth root of the base and then raise it to the exponent of m. And we're going to have to remember that. Let me go back and just pick one. I think one of the previous questions we did was, I better just go back and look, 9 to the 5/2. So this is saying 9 to the 5 over 2 is equal to the second root of 9, then raised to the 5. And I guess what I want to impress on you is that these numbers are just not randomly put somewhere. That the numerator of the exponent becomes an exponent applied to the base that's the radical, and the denominator exponent becomes the index of the radical. Now the example. Rewrite as a radical and simplify without using a calculator. Well, 81 to the 1 over 4 means the fourth root of 81. Now, I can't stop you from using your calculator. But if you have to use your calculator, I would be much happier if you used it this way. What number multiplied by itself 4 times gives you 81? And maybe you'll try the number 2. Maybe you'll see if 2 multiplied by itself 4 times gives you 81, and it doesn't. Then maybe you graduate to the number 3. And 3 multiplied by itself 4 times is 3 times 3 times 3 times 3, which is 3 to the 4. It in fact gives you 81, so this is equal to 3. What about 27 to the negative 1/3? Well, let's tackle that negative exponent first. We know that a base, this is from a previous lesson, raised to a negative exponent, doesn't matter what the letter is I use, is equal to the reciprocal of the same base raised to a positive exponent. These two things are equal to each other. Well, that means that 27 raised to the negative 1 over 3 is 1 over 27 raised to the positive 1 over 3, which is equal to 1 over the cube root of 27. And again, I can't prevent you from using your calculator, but you know, I should have said this earlier. You have to put your faith in me as a teacher that I'm asking you to try to avoid using your calculator because it will be better off for you. You will be better at math if you don't always jump to your calculator. And it isn't about memorizing numbers, it's about developing skills. So 1 over the cube root of 27, we're asking ourselves what number multiplied by itself 3 times will give you 27? And the answer is 3. 3 times 3 times 3 is 27. So this is 1/3. 1 over the cube root of 27, which is 1 over 3. 49 to the 1/2 is root 49. We certainly don't need to write that index of 2. I could have just written root 49 because a square root doesn't require the index to be written, but we should know the square root of 49 is 7 because 7 times 7 is equal to 49. 32 raised to the 1/5 means the 5th root of 32. So some number multiplied by itself 5 times gives you 32. Well, I'll leave it to you to poke around on your calculator and see if you can figure that out. Pause the video if you like. But I would ask you, if you're going to use your calculator, try it by trial and error as opposed to just telling the calculator to find the 5th root. The answer, by the way, is 2. 2 times 2 times 2 times 2 is 32. This is 4. This is 4. This is 2. 4 times 4 is 16 times 2. That tracks, it gives us 32. (64 to the negative 1/2) means 1 over 64 to the positive 1/2, the negative exponent rule we learned in lesson 3. 64 to the 1/2 on the bottom means the square root of 64, and the square root of 64 is 8, because 8 times itself twice is 64. So this is equal to 1 over 8. 8 to the negative 1/3 is 1 over 8 to the positive 1/3, which means 1 over 8 taken as a cube root. And I think we've done the cube root of 8 enough times that hopefully it's starting to stick, that the cube root of 8 is 2, because 2 multiplied by itself 3 times gives you 8. So this is 1/2. Now, when I put this lesson together, for some reason I excluded something that we need to know how to do. So I would like you to turn to page 26 of your unit handout, and we are going to do question 1 and 2 together as examples. So the question is, write the following as a mixed radical in simplest form. Well, 54 raised to the 1/2, we learned in this lesson, is the square root of 54. I'm just going to leave that there for now. 294 raised to the 1/2 is the square root of 294. In the previous unit, we learned that this is called a whole or entire radical. And we learned how to take an entire radical and write it as a mixed radical in simplest form. And way back when we first learned this, we did this in steps. If you need to use scrap paper to come up with this next line because it needs to be done in steps, that's fine. But when you take 54 and you break it up into 9 times 6 maybe, and that's 3 times 3, and then times 3 times 2. And I just want to pause here and make sure you understand what it is I'm telling you. I'm telling you that by hook or by crook, you need to be able to take 54 and tear it apart into its prime factors. And I'm not going to spend time in this video doing that. If you want right now, you can pause and confirm that 3 times 3 times 3 times 2 will give you 54. We learned in the previous unit, through examples and other things, that when you have a pair of numbers and you're talking about a square root, then what you can do if that pair of numbers is written underneath the radical sign is you can extract one of them. Well, you extract both of them, but you write it as 1, and then whatever you have left over, which in this case is 3 times 2, is the new radicand. So root 54 is the same as 3 root 6. 294. Now, I can't necessarily do 294 in my head, so I'll show you the procedure that I would use on my calculator. I know that 294 is an even number, so 294 divided by 2 will give me at least a start in this. 294 divided by 2 is 147. So I can put underneath the radical sign, and I guess I will do this one in steps, 2 times 147. 147 is an odd number, so it is not divisible by 2. What I have taught some of you, if you are not very good with your multiplication tables, and admittedly 147 is not a product I would expect everybody to know, is since you know it's not divisible by 2, try dividing it by 3 and see where that takes you. So 147 divided by 3 gives you 49. Okay, so I can put a 3 times a 49. 2 is prime, 3 is prime, 49 is not prime. Hopefully you know that 49 is 7 times 7. And now you have all prime factors underneath the radical sign. You also have a pair of 7s. And since you're taking a square root, we can extract that pair of 7s and put a single 7 on the outside and be left with 6. Now there's a couple of things. I don't think you always want to be checking every single thing you do in math, but if you wanted to at this point, you could. Let's say it was a multiple choice or a numerical response exam question, and you're stressing a little bit over exams, which we all do to some degree. You could take your calculator just at this point and go, well, what is root 54? Let's see. It is 7.348469,228 something something. It's an irrational number. What is 3 multiplied by the square root of 6? Well, it's the same set of decimals, so that gives you a little bit of a boost in confidence as you move forward on the exam. Again, I don't think you necessarily have time to check every answer. What about root 294? So the square root of 294 gives me that number, approximately on my calculator. 7 root 6 gives me the same number on my calculator. You could also, at this point here, you could also at this point here where you've got all of these numbers and you're ready to finish the problem, you could take your calculator and just confirm that 2 times 3 times 7 times 7 does in fact give you 294. And since it does, you'll be confident in getting the next step written down correctly. Everything in this lesson boiled down to or led to what we're looking at on this screen right here. Understanding how to convert from a radical to a power with a fractional exponent, or from a power with a fractional exponent to a radical. On page 26 to 27 of the handout, there are a variety of questions. You know the drill. You want to do as many as you can, as long as you're satisfied, and I'm satisfied that you understand what's going on. When you take a look at page 26, there's boatloads of questions. You don't have to do every one, but as I say, you have to know how to do every one. So I hope that made sense. As you're watching this video, whatever day you're on, you would then have one more day of practice, and we would have a couple of days of review. So you're looking at your exam being written soon. If you're watching this video on the Monday, which is when it will be available, well, it'll probably be available Sunday night, but if you're watching this video on Monday, November 17th, your exam will be on the Friday of that week. So I hope that made sense, and I hope you're successful with this. Look forward to seeing you soon. Take care.